Welcome to the first video in Chapter 5, Section 3. We're going to look at how we add or subtract things within a trig idea. And so to begin this video, let's just look at some typical ways that we might add or subtract things inside of other functions. Some things that we hopefully are fairly familiar with. Oops, that was an accident. Let's see if I can erase it. There we go. Okay. So for the first one, what happens inside of the squared function? If I have u minus v and I square that, is that going to equal u squared minus v squared? And my idea here is to just pick some numbers, put them inside, and see what happens. So let's just pick 1 and 2. So if I had 2 minus 1 and I squared that, is that going to be equivalent to 2 squared minus 1 squared? So if I actually subtract the 2 minus 1, I get 1 squared right here. And over on the right side, I would have 4 minus a 1. And from that, I get 1 equals 3. And we know that is not true, so that means that is not an identity. The original piece, that does not work for all numbers. Okay, if we look at the second example now, in my video here, we're missing a few things. This is the square root function. So I have things like this written out there. For this, let's pick some numbers that hopefully will work out nice. If we were to pick u equal to 25, so we have 25, and for v we'll have 16. And according to this rule, this, oops, that's not what I wanted to do. Let's see, can I do undo? There we go. Okay, that's what I wanted. Square root of 25 minus square root of 16. If we go through and we simplify all of this, on the left side I end up with the square root of 9. I'll just keep the right side the same for a second. So this is 3. Here I have 5 minus 4. So on this side I have 3 equals 1. We know that's not true. So this idea does not work in a square root function or in a squared function. This idea that we can just kind of transfer that squared idea or the square root idea through and try to make it work with individual pieces. So my question is it going to work, or would we expect it to work in something involving trig ideas? And I hope just by showing you a couple of early examples of things that you're very familiar with, that when I look at this third example and I just say, you know what guys, it's not going to work all the time, that you're going to trust that. So for example 3, I'm not going to throw in some different values. I probably could come up with some examples, but in the end it's going to work out exactly the same as what we saw in examples 1 and 2. It's not going to work out. So someone has gone through and proven the rules that we're going to use for this section. This is getting a little complex, so I'm not going to go through and try to prove it to you. We might talk about it in class at some point. This is also going beyond what I would really want you to be comfortable with. This is really upper level stuff here. I want you to know it exists. I'm not going to ask you to explain how it works or to use it a ton, but I want you to be aware of it, and I want you to be somewhat comfortable with recognizing when you should use it. So in this general area right here, we have some rules that we could look at. If we have cosine of a number plus another number, this is the rule that we would follow. Okay, we would take cosine of the first number times cosine of the second, and we would subtract sine of the first number times sine of the second. Why does it work? There's a proof for it. We're not going to go through and look at it, but there is a proof that exists. And then if we really want it to be, well, I think it is something you should be aware of. If the values inside of these parentheses here were subtraction, then we would just change this to addition right there. And that should be written in your notes as well. So the top description goes with the top description of the second part. The bottom description or the bottom operation goes with the bottom operation on the second part. And that will be true throughout here. So if we were to look at the idea using sine, if I have sine of an angle plus another angle, now it gets a little bit more complicated. It's sine of an angle times cosine of the second angle plus sine of the second angle times cosine of the first angle. So that gets a little bit more confusing. I also want you to be aware, I don't know if I will necessarily ask you to memorize these things, so do be reassured. That's something we can talk about in class if this sounds super confusing. But just like you saw in the cosine rule, if this is subtraction right here, then it would be, in this case, subtraction right there. The rule just changes if we switch the operation. And then tangent is kind of written out for you. I can't think of a place where we actually use the tangent rule in this course, but it does exist. And hopefully it's somewhat apparent that tangent is just sine over cosine. Okay, I'm just going to stop right here, and we will look at these next two examples in our second video.